All right, so today we're going to finish up chapter 3 with sections 3.4 and 3.5. We'll start with some theorems for 3.4. That's really all it's going to be. If two lines are parallel to the same line, all right, then they are going to be parallel to each other. All right, if A is parallel to B and B is parallel to C, then A is parallel to C. It seems like it's similar to the transitive property, but it isn't really, because transitive property is for equality and congruence. And what I would tell you is go back to coordinate geometry. If two lines are parallel, then their slopes would be the same. So the slopes of the first two lines would be like 3/4. Then the slope of the third line, if it was parallel to the second, would also be 3/4. And you notice they'd all have the same slope, so they'd all be parallel. All right, 3.9 in a plane, if two lines are perpendicular to the same line. If two lines are perpendicular to the same line, then they are parallel to each other. All right, and give you a quick sketch of what that looks like. Okay, so basically we'll call this A, B, and we'll call this C. So A is going to be perpendicular to B. C is also going to be perpendicular to B. All right, well, that puts us here. Those angles are corresponding angles, and they both would have to be 90 degrees. All right, therefore the lines would have to be parallel. If you wanted to, you could throw that one to be 90, and then same side interior supplementary, either way you want to look at it. So if D is perpendicular to E and E is perpendicular to F, we are then allowed to say that D is parallel to F. All right, and then finally 3.10, in a plane, if a line is perpendicular. All right, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to, and then it is also perpendicular to the other. All right. So if G is perpendicular to H and H is parallel to K, we would conclude that G would also have to be perpendicular to K. All right, if we want to look at that one really quick. All right, so G is perpendicular to H, which means they make a right angle, and the H is parallel to K. So if these lines are parallel, then corresponding angles would have to be congruent, so that would have to be perpendicular. All right, the major problem you're going to do, and there's going to be two of them. Draw a diagram that meets the criteria listed below, then describe how all the lines are related to each other. So Q is parallel to R, so we draw those in. And then it says R is perpendicular to S. All right. Well, that means from the theorems listed above, Q would also have to be perpendicular to S. So one conclusion we draw is Q is perpendicular to S. All right. And then T is parallel to Q. So there's T. Well, if T is parallel to Q, that means T is also got to be parallel to R. All right. And if Q is perpendicular to S, guess what? T is also got to be perpendicular to S. So this is what we mean by other conclusions. And then the fourth thing they say is U is perpendicular to T. All right. So there's U. So U is perpendicular to T. That means U's got to be perpendicular to R. U's got to be perpendicular to Q. All right. And then finally, if you look at U and S, you'll realize they're parallel. So U's got to be parallel to S. So they're going to look for future relationships when you do that. All right. If you tried this one at home, A is parallel to B. So there's A and B with the arrows drawn. B is perpendicular to C. So there's C, which means A's got to be perpendicular to C. All right. C is parallel to D, so we draw D in. All right. Well, that means that's got to be a right angle, and then that's got to be a right angle. All right. So that means D is perpendicular to A and D is perpendicular to B. They already gave us the relationship between D and C. All right. D is perpendicular to E. So I draw that in. All right, which means that's also got to be a right angle. So C is perpendicular to E. At the same time, EA and B seem to be going in the same direction. So E is parallel to A and E is parallel to B. So that's basically all we're going to be looking for is the other relationships between the lines. Now, the other application we're going to look at involves coordinate geometry and slope. All right, remember the slopes of parallel lines are equal, the slopes of perpendicular lines are negative reciprocals. So A is parallel to B, B is perpendicular to C, and C is parallel to D. The equation of line A, y equals 2/3 x minus 9. If line D passes through point 4, negative 1, find its equation. Now, I would suggest you don't put it on the coordinate plane yet. All right, because if you put it on the coordinate plane, all right, it's just going to be harder for you. So this is what we're going to do. We're going to go back to the drawing we had. So there's A and B. They're parallel. All right. B's perpendicular to C. All right. If you need it, you realize that that is perpendicular to A as well. And C is parallel to D. So they're parallel. All right. Which means D at the same time is perpendicular to A. Why that's important is because they give us the equation of line A, which is y equals 2/3 x minus 9. And since D is perpendicular to A, the slope of D would have to be the negative reciprocal of 2/3. The negative reciprocal of 2/3 is negative 3/2. So y equals mx plus b, since that's what we're trying to find. All right. I'm going to replace the slope with negative 3/2. And then from last year, y and x, I replaced with the coordinates of the point they give me, negative 4 and 1. So the y is the 1, the x is negative 4. Negative times a negative turns this into a positive. It ends up being 6. Negative 5 equals b. So our final answer would be y equals the slope which we got in the first part, negative 3/2 x. The y-intercept we got in the second part was negative 5. Boom. All right, make sure you also brush up on point slope and standard form as well, because that will be involved in future problems. All right, that covers 3.4.